In today's video, we are going to be identifying the characteristics of a parabola. So here we have a parabola, and we're just going to identify a few things on that shape, right? Because it's going to lead us into actually solving for things with the parabola or on the parabola. So the first thing that we might be asked, or you might be asked to identify, is the vertex. And I'm going to have a little bit more detailed description of what each of these characteristics are in the description box. So go check them out if you want more insight to exactly how to define them. So we have a vertex, and the vertex of this shape is pretty much the peak point. That's the way I like to think about it. It's the highest points, or lowest point, and it's written in the form x and y. So the vertex right here would be like right there. So I'm just going to call the vertex 0, 0. The next thing that we might be asked to look for is the x and y intercepts. I'm just going to put intercept. Now this is where the graph crosses the x and crosses the y. So your x-intercept is, right? Because that's where the line crosses the x and y. It's at the 0 point. In this case, it's not always like that. This is a really nice parabola. But in this case, that's where the x and y, the line touches the x, or the y line touches the y. The next thing is your axis of symmetry. Now, your axis of symmetry is axis of sim is usually your x. If you have a sideways parabola, then it's going to be your y. But usually for now, we're going to be talking about just like, the up, the right up parabola, or the down. It could be facing this way or that way. But, it's going to be your x. So where is your axis of symmetry? Where is that line that you can, when you fold your parabola in half, it's going to be like, that's where the seam is going to be. That would be a 0 as well. This is a really, really nice graph. I'm going to do another one. Give you guys another one that's not as nice. And then another thing we're going to be asked is our maximum or minimum value. Now, this is always in the y because it's pretty much what's your lowest value, what's your lowest point, and what's your highest point. And when we're talking about low or high, we're usually talking about the y, because that's the low or the high part, right? Not the left to the right. So when we have our maximum and minimum, if we have our parabola facing up, it's going to be a minimum, right? Because that's low. It's the low part. If we have it facing down, it's going to be a maximum, right? So it's going to be on the top part. That's how I like to think about it. When I think of maximum, I think of high numbers, right? When I think of minimum, I think of low numbers. So when it's facing down, we're going to have our minimum. So we have to state what it is. We can't just say, y equals to 0. We have to say if this is a maximum value or a minimum value. So it's a minimum of y equals 0, right? Because it's facing down. It's low of y equals 0. Now, another thing that we'll be asked to do is our domain and range. I really don't like stating domain and ranges, but we do have to do it. So we have our interval notation and our set notation. Right, the interval is pretty much the brackets, your nice brackets. And it's usually negative infinity to positive infinity. Then we have our set notation, which is like the curly brackets that I never learned how to draw properly. But then it's pretty much x exists in the reals. For this equation, if you had the sideways parabola, it's going to be a little different. But since it's a upper parabola, or it could be a low parabola, either way, you're going to have this as your domain. So the domain is pretty simple. Then we have our range. And now, when you include, and I'm just going to do interval notation first. When you include something, it's always, 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 always a square brackets when you have a number that you're including, right? So in this case, we are including a 0 because a 0 is a point on the y-axis. It is a point right there, but we're not including a positive infinity. So it's going to be round brackets, right? You never include that because it's infinity. It's millions and millions of numbers that are unknown, right? And then we have our set notation, which is going to be y such that slash means such that, y such that y is greater than or equal to 0. And then we're just going to put our other thing here. Now, why is it y greater than or equal to 0? Well, if you go back to our graph, you can only go upwards from here. You can't go down. So y is always, right? Y is always going to be, it could either be y equals to 5, y equals to 6, 7, 8, 1, 2, 3. It's greater than or equal to 0. So our y is always going to be like that. So that is how we find our domain and range. Okay, so for this question, we have a graph that's facing up again. We're going to have to do our vertex, y-intercept, x-intercept, max or minimum value, axis of symmetry, and the domain and range. So again, our vertex is our peak point. Now, this is not as nice as the last graph because now we kind of have to look, where is our peak point? And remember, it's always in the form xy. So right here, I'm seeing a 10 and a -4, right? So we have 1, 2, 3, 10 and -4, right? We have this point right here. I'm just going to zoom in right there. So that tiny little dot, I'm going to put a dot instead. It's pretty much like where the 10 hits and where the well, now that I zoom in, it's not -4 anymore, but let's zoom out. Yeah, and then where the -4 kind of hits a little bit right here. All right, so we have and -5 actually, or is it -4 is right here. So yeah, somewhat around there. So we're gonna have a 10 and -4 is what we kind of came to the conclusion of. Because of what I'm using, once I zoom in or zoom out, it's going to change my value. But we're gonna use our initial value or try to zoom it back to where we had a 10 and -4. Exactly right here. So this is a 10 and a -4. Yeah, lots nicer. Okay, so our vertex is kind of hidden now, but we pretty much have a 10 and a -4, a y-intercept. Now this is where the graph crosses the y-intercept. Now, looking at this, the graph really doesn't cross the y-intercept. But we have arrows at the end of the graph. It means that this graph keeps going, but we don't want to draw it. It keeps going for God only knows when. So as it keeps going, the chances are it could spread out far enough that it's going to cross the y-intercept somewhere along the lines that we don't know. So there is a way to find the y-intercept, right? There is a way. And we usually would need an equation of the graph, which we don't have. I could solve for the equation of the graph right now, but then again, it's just going to make this video a little bit more complicated. So for now, we're just going to say there is no y-intercept. But keep in mind, again, we could solve for the y-intercept. But right now, we're going to say none, just to keep this video very simple. And then we're going to the x-intercept. We have 2, because the graph intersects x. 2 points. So we have our x is equal. Now, it's kind of not nice, but we could say our x is equal to like a 9.2. And our x is also equal to a 11.2. Something like that. They're not nice points, but we can kind of guess. Again, there's a way to solve for the x-intercept to get the exact point. To get the exact point where both of them kind of like intersect. But I don't want to make this video super complicated, so we're just going to kind of guess a point right there, like kind of just looking at it. So for the maximum and minimum, again, this is a minimum, so we're going to have to let them know that's a minimum value. 4, -4. Y is equal to -4. Again, it's usually like whatever your y value is in your vertex. Your axis of symmetry, the easiest way to remember is whatever your x value is in your vertex. That's a 10. Okay, so our domain and range, again, for the domain, again, domain are always x values and range is always y values. Just in case I didn't say that, we're going to have, I'm just going to do one notation this time, just so I don't run out of room. I'm going to have negative infinity. Wow, that looks really bad. To positive infinity. And for the range, we're going to include -4, but exclude positive infinity. Now, let's say this was a maximum value. So let's say the graph was opening down, not up, right? The range would probably look something like the x being here. So it would be -4. -4 and negative infinity. Right? So it's going to kind of flip. But since this opens up, and again, when we're looking at the range or the domain, we always look at it from left to right or from bottom to top. So like this to this, like this to this. But anyway, guys, thanks for watching this video. I hope you guys learned something, and I will see you guys in the next video. Bye.